Hey friends, welcome to follow up. In this video, we're going to look at problem 349, intersection of two arrays. This is a daily challenge problem. So here we want to explain how to use two-pointer trick to address this problem. The statement for this problem is very short. So here we are given two integer arrays, and we want to return an array of their intersection. So here, each element in the result must be unique, and you may return the result in any order, right? So in the first example, we know the common element is 2, while in the second one, we know the common elements are 4 and none. So actually, in Python or in some in a general language, array is different from set, because for set we have uniqueness of elements, right? So here, what we want to return is a list which contains a unique element. So in a rigorous sense, if we regard nums1 and nums2 as two sets, right? And then because this does not affect the result, then we want to find their intersection mathematically. So that's the problem logic, right? So here the constraints for the problem are the following. First, the lengths of the two arrays are bounded above by 1000. So this actually gives us an upper bound for the problem size. Secondly, the elements among the two arrays are non-negative and bounded above by 1000. So they are integer valued. So with that said, we are ready to do the coding. Actually, this one is quite similar to a previous problem for finding the minimum common element in two sorted arrays, right? So here the difference is that these two arrays are not in sorted order. So we can first sort them, right? So if you have 1, you have 2, 2, 1. Then after sort, you are going to get 1, 1, 2, 2, right? So then 2, 2 after sort, of course, is going to be itself. So 2, 2. And then we can use two pointers. So we can start from the beginning. And then we check. So for example, these two, they are not equal. So then we move. Let's put an I here. Let's see. It might be better. So we have an I here. We have a J here. So we compare the two elements. If they are equal, so it means that this is a common element. We're going to add to the result. So it's better to use a set as a container for the result, because if we have common ones, so we're going to ignore, right? So because they're not equal, I is smaller, so we're going to push it to the right. And then we have this one. So now we are going to, because I still corresponds to a smaller element, then we're going to move towards right again. So in this case, we have 2, they are the same. So this two indices corresponds to a same element. So we're going to add these two to the result. And then we're going to move I forward and move J forward. But in this case, again, there's a 2, right? We want to add to the result because it's, again, a common element. However, because we require that the result contains a unique element, so we can because this already appeared in the result. So if I use a set to contain the result, so originally we have already added a 2. So now we can add this 2 again. So the result will still 2, right? So because now they are equal, they are the same again. So we're going to push this I forward and J forward simultaneously. But this will auto bound. This is also our stop condition, right? So this is basically the idea for doing two-pointer. But for doing two-pointer, we need to do sort. The sort actually is an O(n) logarithm n time complexity algorithm, where n is the length of the iterable involved. So for this problem, I'm going to change this to be A and this to be B, just for saving several typing. So what we can do is that we can initialize a result. We are using set, right? So this is in view of the requirement that in the returned result, the the element should be unique, right? And then we are going to have two pointers pointing to the beginning of the two arrays. Let's use I corresponding to A, right? Let me write here in order to make it logically clear. And then what we are going to do is, well, I is less than length A, and so here J is less than length B. So what we are going to do is we do comparison, right? If AI equals BJ, this means the two elements, two indices correspond to the same equal element in the two lists. This is common. So we are going to add the result. So we are going to use the set data structure to help maintain the uniqueness of the returned result. So we are going to add. So you can add AI, you can add BJ, the same. Then otherwise, if AI is less than BJ, then we are going to increment this I by 1. Otherwise, the other side, AI is larger and the BJ is smaller. So we're going to move forward J, right? So afterward, we can return the result. So notice that Python is not strong typed. So here the return should be list of integers. So if we directly return result, actually it can pass all the result test cases. Let's do a test. It's running slow. I don't know why. oh, here I guess there's something so missing. After we do this equal, so we should have I increment by 1 and J increment by 1. So let's do this. I plus 1 and J plus 1. So notice that we should first add, then do increment, right? So let's test it. Yeah, it passes the first example. Now let's look at the generic case. So here output is, I think I forgot something. That's very crucial. So here we need to first do the sort, right? First do the sort. So we can do it in place. So A sort and B sort. So this will do the job. Let's quickly test that. It passes one example. So now let's look at the generic case. It passes all the cases. But if you can, you do a quick time complexity analysis. So this part actually is O n logarithm n. So where n is the length of the array A. So here is the m logarithm m. So this is m is the length of this array B. So for this while loop, is bounded above by O n plus m, the sum, right? Or you can see the larger one if you like, but this is a tight one. So overall, it's a summation of the three. In other words, it involves slightly superlinear because the amplifying factor is a logarithm of the length. So this is the one solution. Actually, this solution is also what we want to present. But mathematically, you can solve it very easily. But that's, I think, is not for coding. It's rather some mathematical thoughts. So you can change this one to be version v1. And also, before we move to the second solution, you can make it a list, right? So this is to obey or to comply with this annotation, right? So, but it return result itself will pass the case. So here, what we do actually is we return the intersection of set A and set B, right? You can check that. Same as the first example. If you want to make it more, obey this one, so you can make it a list, right? But make a set is O of n, say O of m linear, and then you do intersection as O n plus m, right? So this actually avoids using sort. But here our goal is to, expose to you this simple trick for doing two pointer after sorting. So it's important, as we have in our first attempt, we forgot this sort, right? So with that said, I guess that's about it for the current video.